So that was lift. Dealing with the thrust of the aircraft, especially in the propeller-driven aircraft, we have the tendency of the aircraft to either roll or yaw a certain direction because of how that propeller is interacting with the airflow or just certain physics principles there. So our left turning tendencies, something you learned about in your private ground school, may not have touched too much in instrument. Just here back to review it again in commercial ground school. Obviously, you are very familiar with these concepts as when you take off, you know, you're applying a little bit of right rudder to keep the airplane straight down the runway. In that lift off, you're applying a little bit more right rudder to keep the aircraft from yawing at that point there. And, you know, obviously we got a torque reaction going on from the engine. That's working on Bernoulli's principle. For every action, equal the opposite reaction. Propeller spins clockwise as seen from the pilot's seat, so the airplane rolls counterclockwise. That's the opposite reaction. Another effect of the airflow is the spiraling slipstream. So that propeller spins the air around the fuselage. It does have the effect of striking both the vertical stabilizer and the left horizontal stabilizer. And we'll expand on that in an upcoming slide here. Also, that propeller interacts with the air in terms of the downgoing blade is at a slightly higher angle of attack than the upgoing blade. So we have a little bit of a yaw motion happening from that P factor. And the last one is just a physics principle for gyroscopic precession. We have a rotating mass, apply a force on that propeller, it acts 90 degrees in the direction of rotation. For the most part, we press right rudder and we take care of most of these effects. All right. Let's look at spiraling slipstream just a little bit more. Okay. Here is an aircraft where conditions of the day allow you to see the spiraling slipstream very clearly. This is continuing on through the empennage area as well. And we are having two effects. One, because the airflow is hitting the vertical stabilizer from the left side, it's pushing that whole tail section to the right, which that causes a left yaw to happen, right? But what a lot of pilots don't understand is the spiraling slipstream also strikes that left horizontal stabilizer from the bottom. Ooh, that's different, because striking the left horizontal stabilizer from the bottom induces a right roll. So that's the FAA knowledge test question there. What happens with spiraling slipstream? Well, it's a left yaw, but it's a right rolling tendency. Okay. So just keep that in mind. That is it's a little opposite of what you may have thought it was. Let's just try a top hat question to help reinforce that one. You can click on two statements about spiraling slipstream as it hits the empennage here. All right, so hopefully you got that one right, and most of you did get it correct. Okay. So answer B the airflow does not hit the right side of the vertical stabilizer. It is hitting the left side. Answer C, airflow does not strike the upper surface. It is coming from beneath the left horizontal stabilizer. All right, and just a quick video here to show you a little bit from this departing de Havilland twin. You can really see the effects of spiraling slipstream even on the twin here. So that's still going throughout the fuselage there to the empennage. Just because you can't see it doesn't mean it disappears. It does continue all the way there.